As you can see here, we imported our means database from our Keras datasets, and here we try to plot the first 25 images. This were the 25 image, and here we try to see the shape of our test dataset. We had 28 by 28 pixel image. We had 10,000 images for testing, and we also had 60,000 for training. And this is the first image, and this one was to see the first 10 images to see how they look like, and here to see if randomly pick some 10 images and see how they are represented. As we can see, most of them are represented in a uniform way, and here we try to build a mean face to see what the mean looks like, what the average face looks like, and it basically looks like somehow an 8, and here we try to plot a deviation from the mean. This is the SDV, or standard deviation image, for our dataset. And here we try to load some confusion matrices and PCA, and here is the PCA. We used PCA for a dimensionality reduction, and we used to reduce the dimensionality to 2 for a 2D array representation of our training dataset, and we plotted it to see how it is represented, and we started pre-processing after this. First we tried to normalize our image by dividing it by 255, and after that we applied different filtering techniques. Here we applied Gaussian filtering for noise reduction, and here also thresholding for image segmentation, and here for Canny for face detection and feature extraction. We also used PCA again for dimensionality reduction, but here we used 50. So here's our data sets. We had 60 images for training, and 60,000 images for training, and 10,000 for testing. We also have labels here. And first we try to build a basic logistic regression model to measure our accuracy, or basic accuracy. So we used logistic regression, and we found 93.3% accuracy. So this is a baseline, so whatever models we have below this, we have to improve some part to at least get here. So using this, having this in mind, we used a basic model here. This one is a sequential model, and we added dense layer here, and we used softmax, and we had 10 nodes, and we have also configured early stop here. So after training, we set 100 number of iterations or epoch, but here it stopped after 6. This is because we have set our validation accuracy, and this accuracy started to not grow and not fall with a certain range, so stopped over there. And we had a final accuracy of 97.7% of total accuracy after 6 epoch. As you can see, the accuracy started to grow after a certain epoch, and here as the number of epoch increased, the loss started to decrease with a range, final loss range of 5 to 6. And after this, we tried to plot a confusion matrix. As you can see here, zeros, ones, and other numbers were predicted right, but as you can see, after 2, it started to lose, to grow downwards. So as you can see, 8, most of the 8 were predicted right, but 133 8s were predicted as 5, and so as for 9, 762 was corrected right, but 175 were corrected as 7, predicted as 7, so we had to improve this. We had a record value for them for about 73%, so we had to improve this. So we built another sequence or as a model. We added a dense layer of sigmoid and another sigmoid layer, three sigmoid layers, and one softmax layer. And we, since we had a number of layers here, we didn't want to overfit, so we included another regularization techniques. We added dropouts and L2 regularizations. This was how our model looked like, and we used 20 epoch to iteratively test our machine, and we removed the early stopping so as not to stop after six and few iterations that we needed. So we didn't want to surpass the range, so we used 20. As you can see, we had an initial accuracy of 82% work, but finally we had 95.7% accuracy. And our test accuracy became 95.5%. And as you can see, as the epoch increased, the accuracy increased, but there was a jump from 82% to 92% within the first few epoch. And this was epoch versus loss trace. As you can see, the final loss became from 0.1 to 0.2, not as bad as the first model, which was 5 to 6. And we tried to build a confusion matrix. As you can see, the confusion matrix, most of the values were predicted right. As you can see, we had an improved value for 8 and 9 here. We had an 93% recall values here, and final accuracy of 95.53%. I have finished my presentation, and the next presentation would be from my colleague Elias about the next thing that we did after building this model. Thank you.